1X Developer Podcast.
Hey guys, welcome back. It's me, Colin.
And me, Brendan.
And today we're going to talk about some complex ideas, like complexity itself.
So this week I was thinking about something that I had termed the universal theory of the engineering mindset. And I was like all ready to write a, big white paper on it. But then Colin informed me that no, like people have studied this. It's already an idea.
What is the acronym for universal theory of UTOEM? That's not a good one.
Yeah, what's the O?
Of?
Oh, right.
We could take that out, yeah.
UTEM? UTM.
UTM, yeah. The UTM concept.
But I was just thinking about, in previous episodes, we've talked about this idea that developers like making their systems complicated. They like, we were talking about my double-sided accounting system, which is like I use a Ledger CLI to keep track of my finances, and it's like a plain text file that's like a double-sided accounting system. I was also talking about syncing my Obsidian Vault with Git, and these are like complicated things. And there's, sometimes I look at these systems that I've set up and I'm like, what am I even doing here? Why am I making this so hard? But I think that there's something about the mindset of people who get into programming that they really like that. They like complicated things, that they like making things complicated. And we're kind of talking about, why is that? Why do we like doing that? And I really think what this theory I was developing this week was, I think that we like, the mental challenge of wrapping our minds around processes that are complicated but that we can understand. We loathe complicated systems, complex systems. We loathe complexity when we don't understand it, but we love the challenge of being able to wrap our minds around it.
Absolutely, yeah. And I think that's 100% true with really, I think pretty much all tech people in some way. Everybody who programs, I think you've had that moment where like you saw a line or you saw a function and you were like, oh yeah, that was a good one. Yeah, we got in there. And then you think back, you're like, is this readable? No, hell no. No one knows what this does, but it was good.
That's one of the parts of my theory, is that you as an engineer being able to understand the thing has nothing to do with other people understanding it. And we like harnessing that complexity. We don't care if other people are able to are on the same wavelength and can understand what we did.
I think some of the excitement might come from other people not getting it, right? I don't, it's not that impressive if 2 + 2 = 4. Something that just came to my mind is I read this book, I think it was The Kobold's Guide to Board Game Design. I read part of it. And one part he was talking about how a lot of designing a good game is knowing what the fun of your game is. And he talks about it in kind of an abstract way, and he gave the example of actually, now I think about it might not have been that book, it might have been a blog post or something. But I saw that somewhere, and he was saying that Magic the Gathering, the trading card game, which is a very complicated game, the reason why people find it fun, the thing that makes it good, is that it makes people feel smart. That's the thing. When you bait someone into playing something and you play that thing that they didn't see coming at all, that's the magic of the game, right? Is when you feel smart from playing the game.
Yeah.
And I think that, that's the appeal of a lot of things, right? When you feel like, hey, I'm really smart. I put that together.
That's absolutely part of the engineering mindset, is wanting to feel smart. Yeah, that's a really good point. Yeah. I think there's a real, when it comes to jobs and stuff, I think there's a real maturity in kind of like putting that aside for the sake of readability, right?
Oh, yeah.
Doing the boring thing so that someone else can come along later and maintain your code.
One of my favorite sayings is the best line of code is the one never written.
Yeah.
And that's so true. Like the good commits, like we talk about productivity a little bit here. And, you know, a lot of people try to measure productivity in like lines of code added. But like when I see a commit that deletes a bunch of stuff, that's when it's like, okay, yeah, this guy's locked in.
Yes.
We're doing it. We're doing it.
100%. Whenever I see a commit that's like mostly removing code, or even, man, I kind of wish sometimes at work that we would do things like, last year our code base was this size, this year it's this size. I would really want to see, like, I want to see that number go down. I want to see less lines in the code base.
Or when you remove a bunch of packages, that's
Yeah.
really good because it's not even my code.
I have a thing right now where I'm thinking about removing a dependency entirely on an external system, and I'm like, oh man, that's gonna be real good.
Oh yeah. So I guess we should talk about, before we get too deep, complicatedness versus complexity, right? And this concept, because if we're being particular, tech people like things that are complicated.
Yeah.
And really, usually things that are complicated in a way that they made complicated,
Yeah.
right? Or a way that something that's complicated in a way that they understand.
Right. I think that's
That they're good at.
a
Yeah.
way that they can wrap their heads around and that they understand.
So something that is complicated is something that has a lot of details to it, is not an easy problem to solve, but is solvable and measurable in how it's solvable. And, you can create a pattern for solving this problem. What were some of the examples we looked at? Building a rocket ship, heart transplants, medical procedures. These are things that have a lot of steps to them, a lot of details to them. But there's a procedure to do them, and they can be done well.
Yeah.
Something that's complex is something that has a lot of unknowns, a lot of unknown unknowns. There's elements of it that you don't even understand. So something like climate change, socio-political things, things involving people, things that are very unpredictable are complex problems.
Right. Yeah. And I think trying to take a complex problem and like break a chunk off and turn it into a solution that may be complicated is really, it's what we like doing. It's when we try to take a chunk off a complex system and come up with a complicated solution.
Would it be fair to say, because a lot of organizations, they kind of separate like tech people from like people, right? Like business versus tech.
Mm-hmm.
Would it be safe to say that tech people are complicated problem solvers, or at least that's what they like, whereas the people managers are more like complex problem solvers?
Yeah, I think that is fair to say. So I think that whenever we're talking about these complex problems with unknown unknowns, a lot of the unknown stuff comes from people. It almost always involves like human behavior that is not predictable. That's what introduces a lot of unpredictability into a complex problem.
Right.
So I think that's right. Yeah, that people with soft skills or whatever you want to call it are they're the ones who are dealing with complex problems that are human, in the domain of humans.
Right. Right. Because not that software engineers don't work with people, but like when we're doing the computer stuff, when we're looking at the software stuff, that's complicated, but we know we have like clear metrics on what we're trying to hit. We usually know clearly what we're trying to make, and we have clear parameters on what's possible. Whereas managing someone is complex because literally, the people that you work with could have anything going on. They could have any kind of problem. They could lose their memory They could decide that they just don't want to work anymore. They could get really motivated for something. The possibilities are pretty much endless.
Yeah. I mean, something like, they're going through a divorce and are no longer acting in the way that you would expect them to, right? Like their values have changed. They're not rational in the way that you expect them to be anymore. Mm-hmm. Do you think those roles should be totally separate? Do you think companies should have people and engineers and never the twain shall meet? Or do you think there should be some crossover?
I mean, I think there has to be crossover, right? And most organizations have that. Like, they might call someone like software solutions architect or whatever, but a lot of the times that person is largely kind of a manager. That person's in a lot of meetings and stuff.
Yeah.
I would say that complexity, I think, is something you can't get away from at work unless you're just a one-man band. But even then, you don't know what your clients want. Yeah, I think complexity is going to be an issue no matter what work you do. I think about it.
I think anytime you're dealing with humans, I think complexity is just going to be part of the game.
Because look, if your job is only complicated, then we should have a robot do it.
Right. That's the thing, is that complicated problems, even if the solution is complicated, even if it has a lot of steps to it and there's a lot going on there, the whole point of complicated solutions is that we've designed a recipe, we've designed an algorithm, we know most of the things involved, and yeah, we're able to create a repeatable series of steps to solve the problem. So yeah, I agree with that. If all of the things that you're solving are just complicated, we can probably just automate it.
Yeah. And I think that's where I first heard this differentiation between complicated and complex problems is with like AI problems. Because complex things are something that, AI systems are notoriously bad at.
Yeah.
Right. Dealing with unknowns that they don't even know about.
Right. How do we deal with those? Like, what do you think is the model for us when we encounter a complex problem?
That's an interesting question because I get the sense that, okay, so a complex problem cannot be solved purely algorithmically, right? Mm-hmm. But you can approach complex problems with an algorithm, right?
Yeah.
Like interpersonal relationships, you can approach conflicts with I think we used to do this in school, right? They have like flow chart kind of things, where it's like step 1, assess your feelings. Step 2, articulate them clearly. Step 3, apologize. Something like that.
Yeah.
You can make patterns for complex problems. You just don't really know what's going to happen, I guess.
I think that's it. It's just the outcome is less certain. We would still consider those complex problems, I think, because people are likely to react in some way, but definitely not guaranteed. Mm-hmm. People are people.
Yeah. Are there complex problems that don't include a human element? I guess animals also, but complex problems that are non-organic. Is that a thing?
That's a really good question. I would think there have to be things that involve, I bet there are things out there that I just don't know about that involve chemical reactions and things that are not exactly predictable, trying to think of
there's physics stuff that also, I'm not smart enough to talk about, but quantum entanglement or whatever, it's supposed to be completely unpredictable, at least with the knowledge we have.
Yeah. Yeah, I think there are probably things like that. I think for most of the things that you and I are dealing with, it probably comes down to humans.
Right. Oh, well, I mean, there are always things, even in problems that we view as being complicated, there are always things that we can't predict that can happen, right? Like a meteorite dropping out of the sky. Something that was just never considered as part of the system at all.
Yeah.
I guess that's that's just like a high level of complicatedness, really, more than complexity.
Yeah, I think. I mean, I do. I think in any system in the world, there are things like that that can happen. There's solar flares and flipping bits and things like that. I think that at some point you do have to draw the line and say, if you repeat this algorithm, if you repeat this recipe, you're going to get the result that you want almost all of the time. Yes, there's a 1 in 10 million chance that something weird is going to happen, but for the most part, this thing is subject to like repeatable steps.
Yeah. I'm reminded of, man, I'm going to mess the story up, but there was like a, I think Mario 64 speedrunner who, okay, so like speedrunning is like a whole rabbit hole of video games, right? You try to play the game as fast as possible, and there's like world records and stuff, right? And Mario 64 is a really popular game for speedrunning. And a big part of speedrunning is finding glitches in the game, right? Like, oh, you stand next to this thing and you do this certain input and you can like go through the wall or whatever.
Yeah.
And there's literally people who like will play these games and just do basically random inputs at different parts to try to find stuff. They've also done like tool assisted, looking at source code and stuff. But there was a speedrun and it was live where a guy, and I haven't played Mario 64, but he just like Mario just like shoots up into the air, and it was a part of the game where he's trying to like climb up a tower or something. So he just shoots up and he skips like probably like 20 or 30 seconds, I guess, of his run, and it just happened out of nowhere. And people spent like months trying to recreate it, trying to see what could have happened. And in the end, someone looked up that there was a solar flare on that day.
Really?
Yeah, and it's like it's pretty much understood that there was a solar flare that flipped a bit somewhere, and I think they even identified that like there's just like a y-axis location bit that was switched, and it made him go up into the air, and no one's been able to recreate it since.
That's so weird. I mean, I've heard about that's a real thing, that solar flares can flip bits. I didn't know they could. Can they trace it back to events like that, though?
I think it's more just the fact that, like, what else happened? Like, there's really not another, like, reasonable theory for what happened.
Right. What's that quote? Like, how when you rule out everything that's probable, you end up with the solution that's the least possible or something like that.
Yeah, that's it. Exactly. You got it.
Sounds right.
Yeah, no, I mean, how an ionizing particle from outer space helped a Mario speedrunner save time. It's in 2013.
So he was playing this game and even he was surprised by it? He was like, whoa, what the hell was that?
There's a video of it and he's like, whoa, what? And then he just keeps going. And I don't think he hit a record because I think he just had a pretty normal run otherwise. But, and also I think, if I remember right, a big part of this is that it was live streamed. Like, if it wasn't live streamed, people would be like, what? I don't know, you were cheating or something.
Yeah.
So, yeah, weird.
But a bunch of people saw it happen in real time.
Yeah. Why was I talking about speedrunning? Because it's complexity in a system that we would normally view as being complicated.
Yeah. Well, yeah, we're talking about solar flares being like the introduction of just total randomness into what would otherwise be a predictable system.
I mean, like, I think there's something there about, like, that system is still really complicated. There's still rules to, say, solar flares, but we don't understand them, but we theoretically could, right? Like, in a physics class, you always come up with, like, in physics problems, there's always like, okay, ignore friction, ignore air resistance, ignore this, just focus on what you know. But, like, the real world isn't like that at all. There's so many things moving all at once in the real world that it's so hard to calculate stuff.
Yeah.
But it is theoretically possible to calculate everything. So I think solar flares, like, you can view them as complex from, like, a human standpoint, but if all knowledge was available, it would be complicated. right?
Right. Yeah.
Like if there was a way for me to measure the exact state of the sun right now over its entire surface and inside it and everything, which I could never do, but if I could, it would be complicated.
So are we getting into a discussion here about like whether the universe is deterministic?
Pretty much, yeah.
Is it so?
Because that does kind of beg the question, like, I mean, if I could like measure the neurons in everyone's brain, would I be able to calculate every possible outcome? Like, will I know what happens tomorrow? I guess I would.
Yeah. But don't we know from quantum mechanics that that's not the case? That there is inherent unpredictability. We're talking about Schrodinger's cat and like the uncertainty involved in that.
Yes.
Is there uncertainty at the very heart of reality? You know what I mean? Is the universe deterministic?
I mean, honestly, something I think a lot about is like, and there's philosophical terms for all this, but how do we even know that like what we're measuring is real, right? How do we know that like what we're seeing with our eyes is real? You know, you can get that deep if you want to.
Yeah.
What if we're all plugged in the Matrix? We wouldn't know.
But we've come up with these systems that are, I mean, I think the scientific method is really the best thing that we have to kind of combat those kind of questions, right? We can say, given a certain set of inputs, if we repeat this experiment with the same inputs, that we can like measure the same output every time.
Yeah.
And if we do that enough times, that we have some confidence that if we repeat this recipe over and over, that we're gonna come to the same result, regardless of how complicated those series of steps in that algorithm is.
Right. Well, if we control the parameters as much as we can.
Right.
Because there will be things we can't control, and that's why, like, you know, some percent of the time the results will be wrong.
And that with the heart surgery one, we were talking about, you know, doing all the steps does not guarantee 100% that the surgery will be successful, but we kind of know what can go wrong if things go wrong.
Right. Yeah. So something interesting to think about with this whole topic is the concept that maybe complicated systems or solving complicated problems is like almost a way to combat the complexity of the world.
I think that's exactly right. I think engineers don't like complexity. They don't like not being able to wrap their minds around the totality of the thing, right? So they encounter this complex world and they're like, I don't know what to do with this. I think that's what I mean by the engineering mindset. I think that's really, really at the heart of it, is you encounter this complex world and you're like bothered by it. It gets under your skin, yeah. Right? The fact that you can't understand it is really annoying, or really you kind of like detest it in some way. And so you try to break it off into pieces and you try to create these complicated solutions to pieces of it. Like you said, when you're controlling for certain variables, we can now create a recipe for this little chunk of this complex system.
Right.
And we can make it complicated.
And you hear that sometimes, right? People say like, oh, I don't like people because I don't understand them, so I like computers.
Yeah.
You know, there's a lot of that in the tech world. I saw this documentary a few years ago called Keeper of Time, and it's probably like the best documentary I've ever seen. And it's about watches and watchmaking. And something that they talk about in the movie is how, first of all, how time, the concept of time and the passage of time is just so freaking spooky, right? It's such a like, it's something that no matter what, you cannot fight against it, right? Mm-hmm. There's literally no way to stop time, to turn back time. Events will pass no matter what, right? And when you start thinking about it, it's just so freaky, right? It's such a big idea. And they kind of posit in the movie that in a way, watchmaking is like this like statement against that, right? Like maybe if I can measure time really, really accurately, that will give me like this little bit of control over it. right?
Yeah.
I'm fighting back in a little bit, in a small way, against this inevitable thing.
I think so much of it has to do with control.
Yeah. And what's interesting is, I mean, so watches are a great example of a complicated system. You know, they're very complicated. And they're not complex, right? And one thing I find kind of ironic is that all the little subdials you see on a watch, like the little date thing and the like whatever else, you know, the what do you call it? Like compass, whatever. Those are all called complications. That's what watch people call them. It's like, oh, look at all the complications on this watch.
Yeah.
Because they make the system more complicated. So, cute little thing.
That's funny. Oh, no, I think you're exactly right when you're talking about control. Like, trying to exert, I think that's what we're doing and what we want to do when we're trying to tame a complex system and we can't really, like, get our heads around it and stuff. We're trying to exert some kind of control over it. I think that's what I mean when I say that we loathe complexity, is that we're trying to grab some piece of it and like make sense of it, and it's really is about control. We feel out of control when we don't understand things, and we try to just exert some control to kind of like, I don't know, show. Well, first of all, I think it's fun. I think a lot of people just think it's fun to do that kind of mental exercise, and it makes us feel smart, like we were talking about. But I really think there's like something psychological about exerting control over things by doing that. Yeah.
So what's something that you make complicated? I mean, you gave an example of your accounting thing, but like, I don't know, what's something else that like, or you just get a kick out of how complicated it is in a way?
Something that's not programming related?
Yeah, something else.
Well,
I mean, I guess it could be.
I guess the other thing would be music. So I make music, and it's kind of interesting.
Well, you think I mean, because there's like the math rock nerds who are really into like the super complicated time signatures, and I mean, I like a little math rock, but it's like, it's kind of something I look at like, you guys are really getting a kick out of this, you know? Like,
yeah,
it's cool. I'm happy for you, but you know.
Yeah, making music is probably the other one. I think that really, I really feel like making music is, again, a kind of like taming complexity. You start with like these possibilities. There's just this possibility of like every note in any formation, you could just play all the notes at the same time, right? You could just lay down on the piano and just like play every note, but it's bringing organization to that chaos. And it's an extremely complicated process that's like, involves, I don't know, that's an interesting one, because I hate to call it complicated because it doesn't really come down to a series of steps. You know what I mean?
Yeah.
The creative process is a little mysterious and weird, but at the end of the day, there are things, the process itself is a series of repeatable steps. I listen to the song, I think, what could be different, and I tweak something, right? And basically just do that over and over until you have a song.
Yeah, I mean, that's a whole like weird philosophical concept, right? Because I feel like music is complex, definitely in ways. Like, to me, music is more about the emotional impact, right?
Mm-hmm.
Than really the like the mechanics of what happened on the instrument or whatever.
Yeah.
Which emotions are incredibly complex. And then also, I mean, I wonder, like, okay, so a piano is complicated, right? Because it makes these 88 plus the Black Keys notes. But then, like, string instruments, I mean, I guess there is a range of audible frequencies they can do, but I feel like there are unknowns on what an instrument can do. Maybe not.
Unknown. What do you mean by, you mean the sounds that it can produce?
Yeah. I mean, I guess the sounds it can produce are known. But like the song compositions are kind of endless. I know this is a thing people debate about, is like, is there an upper limit to how many songs there could theoretically be? And most people, when they talk about that, they're talking about like in like how many catchy tunes are there, right?
Right.
How many melodies are there, which is largely believed to be finite. But when you think about song compositions, it's effectively infinite, right? I mean, you've got different lengths of songs, pretty much an endless combination of lyrics, so.
Yeah, there's no reason songs need to have verses and choruses at all, right?
Right.
Have you ever heard that term through composed?
No.
It just means like that, a lot of songs have a structure that's like A, B, A, C, something like that. Through composed just means like an A section,
you start
B,
at the
C,
beginning.
D, and it just keeps going. You don't repeat or come back to sections.
Uh-huh.
So, yeah, I mean, I think for anyone that's like experimenting with song structure and stuff like that, I can't imagine that's finite in any way.
Yeah.
Especially, it almost seems like, think of the largest number and then add one.
Yeah.
Someone could always just make a song that's the same as that last one, but they add another section to it.
Exactly. Yeah.
What about you? What's a complicated thing that you do that's not programming?
Well, I think games, video games, and board games, generally games. This is still kind of programming related, but I've been I screw around with like Linux distros, and that's a case of like making something kind of harder on myself that I don't really need to.
Mm-hmm.
But I just get a kick out of it. I mean, there's other reasons why I use Linux distros, but that's part of it. It's like, hey, I'm doing this complicated thing and I'm having fun.
Yeah.
Something that crossed my mind is I'm not like a writer, but I've read a little bit about like screenwriting. I just find it interesting. And something I was thinking about is audiences don't like a simple story. Sometimes they do, but usually there's something else about the story that is drawing them in if it is simple.
Yeah.
Generally, I think audiences like complicated stories that have like things you didn't see coming. Complicated in that sense, right?
Yeah.
And I think sometimes, if you're ever watching like a mystery or a thriller, a big part of it is that like feeling smart at the end, right? Like, ooh, they set up all those things and I didn't see it. That's so smart, right? That's so complicated. Like Christopher Nolan is like famous for being complicated, right? But what I just kind of occurred to me is that audiences really don't like complex things, right? And what I mean by that is like when the story does something that was completely not set up, completely unknown and chaotic, right? When characters do things that don't make sense for a character.
Mm-hmm.
A lot of audiences will complain when, for example, a character that is known for being dumb does something dumb. So like a really good example would be like Goku letting his enemy power up so he can fight him at full strength. That's a very dumb thing to do, right?
Yeah.
But Goku does it every time. So that kind of like makes it okay for me at least. But what would annoy me is if a character that's not known for doing something dumb, like if a character like Batman, who's known for being very smart, were to let the Joker set up his whole scheme and then fight him at the worst possible moment, right? Batman is a guy who tries to be strategic all the time,
Yeah.
That would feel complex because it's going against the rules that have been set up for me.
Yeah.
This is something that comes up a lot in like world building for storytelling too. Like there are worlds that have silly elements to them. You see that in like fantasy a lot of the time. Like it's okay for magic to exist in a world. What's not okay is when the rules of your world start to collapse on themselves, right?
Mm-hmm.
Like when, okay, so a way that Dragon Ball is complex would be how a character shows up and says he's the strongest guy in the universe, and then the hero beats him, and then the next bad guy shows up and says that he's the strongest guy ever, actually. Right? It's an unknown that was introduced because I would consider that bad writing, right?
Yeah.
That's just something. So I think in storytelling, we like complicated stories, but we don't like complex stories.
I think complex stories, maybe the unknowns that we're talking about lack resolution. You know what I mean?
Right.
It's like you want as an audience member, you want a story to resolve. You want it to land in some place. Maybe in music too. You often want a melody to resolve and to land in a place, right? Yeah, I think a complex script or like a complex book might feel like it doesn't have resolution because it's not, things are left unknown.
Yeah, but I think part of it is like a complex story feels like you cheated, right?
Yeah.
Like a lot of people point to the death of Superman as being like the end of comic books being good. So like the whole story arc was basically Superman dies and guess what? He comes back to life. And a lot of people even at the time were like, okay, this is what Superman sucks, because if we can kill characters and bring them back, there are no stakes. And I feel like that's something that it kind of relates because, like, okay, Superman has pretty clearly defined rules, right? He has really, really strong, he's really, really fast, he's weak to kryptonite, that can kill him, and a few other things. But when we introduce that when he dies, he can come back, that feels like you cheated. It feels like you broke the rules of the universe. It feels like when people die, they should be dead.
Yeah.
Right.
I don't want to get any hate mail and like make any hot takes here, but I tend to not really like the Marvel movies because I feel like they do that a lot. Mm-hmm. As you go along in the Marvel movies, I just feel like characters are introduced often. It's like they introduce some kind of thing that breaks the rules.
Yeah.
And it's like, oh, there's a guy who can do that. It's like that we haven't heard of for the last 17 movies.
Yeah, totally. That's a big thing. Like, especially when you watch that first Iron Man movie, which is just like a guy building a suit.
Yeah.
And then now Doctor Strange is like generating, he just like builds a city around everybody. Like, I don't know what's going on.
But it would be like if we introduced magic into the Batman world, right? Like,
yeah,
it's a violation of the rules.
Yeah.
The rules, quote unquote.
Yeah. That feels like you're cheating. Because games are another one, right? Video games are complicated, but they're satisfying because when you understand how they're complicated, you can do really cool stuff.
Yeah.
Complex games can still be fun. The only example I can think of a complex game is like a physical sport, where the outcomes are, or like the things that you can do are virtually limitless.
Yeah, again, I think it's the element of human involvement, right? Any kind of board game or anything like that has clearly defined rules that, assuming you're not cheating or something, you play by these defined rules. But sports are very different because they involve humans who are doing this competition on any given day, right? And they bring all of that human complexity to the table. Maybe they're hungover that day or whatever.
Right. The like there's still parameters of what they're allowed to do, but a human can move their body in virtually limitless ways.
Yeah.
Kind of, what was it called? Like the Fillsbury Flop? What was that? You know what I'm talking about?
Uh-uh.
So like supposedly in pole vaulting, like originally people would just go forward over the thing. They would just pole vault like how you would approach it normally. And this guy, I think his name was Fillsbury, that's why it's something like that, that's why it's called that. And he was the guy who went backwards, how they go over their back.
Oh, yeah.
And it just blew everyone's mind because everyone was like, oh, I didn't know you could do that. And supposedly he wasn't even really that good either. He just like was the first guy to go that way, and it was like a way better technique to do it.
Interesting. I didn't realize they didn't always do it that way. Yeah, I thought that was like back to ancient Greece.
I feel like this might be a like old wives' tale or something, but it's something I read when I was a kid.
But that's like that's weird.
Fosbury.
The Fosbury.
Fosbury flop.
When was this?
Well, he won a gold medal in 1968 in Mexico City.
Oh.
And then, yeah, the flop became a dominant style of the event afterwards. Most elite jumpers used to use the straddle technique, the western roll, the eastern cutoff, or scissor. How many different ways can you jump, honestly?
Yeah. I'd like to see all of those in action and kind of compare and contrast.
Yeah. There's a diagram of the Fosbury's flop, but these other ones don't really have. I mean, this is an audio podcast, but this is the straddle technique where so you can hardly tell, but she's going forwards.
But he's doing one leg at a time. Is that it? It's like doo-doo?
I guess, or he's going at an angle, maybe, kind of.
Yeah.
I guess that's why it's the straddle, right?
Yeah.
There's no pictures of these other ones. Oh, okay. The scissor jump, which is you're lifting one leg up and like scissoring your legs.
You coming out sideways.
Yeah, I think you're coming sideways. The Fosbury flop is you're going backwards, and that's what they do today.
Okay. Yeah, that's the only kind of pole vaulting I've ever seen is the backwards.
I don't think the other ones are even worth doing anymore.
I mean, that's a little. People can push sports forward within the bounds of the rules. Is that really complexity? Right? Like, so you're allowed to go over backwards. It's just nobody did it until somebody was like, hey, what if we went over backwards?
I think that's still because I literally just said, like, how many different ways are there to jump?
Yeah.
There's got to be a finite number of jumps you can do.
Yeah. Until
But I mean, if this kind of goes back to what we were talking about before, like the solar flares and stuff. But like, if you think about like the wind and like, I don't know, just the exact way that the pole, does it go into a thing? Is it just in a track? I don't even know how this sport works.
Yeah, I don't know.
Example.
I think it does go into a thing because they seem pretty confident when they jam the thing in there. You know, it's like, okay, you don't want to miss.
Okay.
Let me ask you something. Have you ever met somebody who you felt like did not have the engineering mindset but ended up being a coder anyway? Because sometimes people will...
Oh, yeah.
I feel like sometimes people will ask, should I go into programming or something like that? And I feel like there's a very specific kind of personality that I'm calling the engineer mindset here. That like, if you don't have that, and you spend your days as a programmer, I think that's absolute hell. I think it would be terrible.
No, yeah, I've worked with people who seem to kind of did that. You know, they saw what looked like a good career, and then didn't have that like. They didn't want to understand things deeper. They didn't seem to really have a deep interest on the things, and they found like. I'm thinking about it because like this is a specific individual, but so he's probably not going to listen to it. But he ended up kind of transitioning into a like project manager type role, and he's really good at that. And that's like a really nice happily ever after story there.
Software adjacent,
right? Because he had skills, you know, but I don't ever get the feeling that he was, he had that engineer mindset you're talking about.
I just think that's really interesting because, like I said, people have asked me about that, and sometimes I've been like, "No, I don't think you're." It's not to be a dick or anything, but it's just like I don't think that you have that. I think maybe you're more comfortable with complexity than I am. That you don't have that need to like try to harness it. But I think that most programmers, at least the ones, with that engineering mindset, just have that desire to like harness complexity.
Yeah. And it's I get what you mean because it can feel like we're being kind of egotistical or something, but no, it's a specific type of thinking. It's a specific type of mindset that I don't know. Can you learn that mindset? Is that something you're born with?
I don't know about born with, but I do think it's hard. I think it's really hard to develop it later, if it's even possible. That's not, that's very different than saying you can't learn to code, right? You can, that's kind of why I was asking about people who are doing this but don't have that way of thinking. I think those are kind of two separate things. You can learn to code and be a perfectly good coder, but it just seems to me like it would be a really hard road to do that if you didn't like solving puzzles and you didn't like playing Zelda as a kid or something.
Yeah.
It's just like at least for me, I think there's a very direct connection between video games that I liked playing as a kid and programming. And I think that, yeah, I don't know that maybe you can develop it and kind of like learn to do it, but I tend to think most people don't.
Yeah. It's interesting because like you do notice that there are specific types of like cross-pollination in like software people, right? Like you mentioned video games, but also like music. Mm-hmm. There's like, not all, there are like software developers who are really in music or whatever, but it seems like you meet a lot that are musicians,
Yep.
And also with martial arts, I feel like there's a lot of martial arts people into software.
What do you think that's about? What do you think the connection is?
Dude, I don't know. But I mean, like, I know John Carmack does judo, and Lex Friedman does jiu-jitsu famously. And I've met a lot of, at jiu-jitsu, like, you meet a lot of programmers. I don't know.
Is Lex Friedman a programmer?
Maybe not really. He's like, I think he's like an AI, he taught like an AI class or something like that.
I sort of know him from his YouTube stuff, but...
Yeah, I mean, like, like, I've seen clips of him talking to John Carmack, and he, like, is knowledgeable about languages and stuff. It's just something I've noticed personally. Yeah, I don't know. I mean, I think part of it really might just be more that it's like a physical thing that you can do, because that's, programmers naturally kind of go, dang, I need to get up, move,
Yeah.
And
yep.
It's a physical thing that you can do that is kind of because also like rock climbing, I feel like there's a lot of rock climber developers. I feel like that's kind of a similar thing. It's like you reach a certain income class as a white person and you just start rock climbing.
Is that right?
You know what I mean? And you start drinking IPAs and stuff.
I've never been to the rock climbing gym, but
I went once.
I've always wanted to.
But I feel like there's it's okay. It's like it's rock climbing, martial arts, or cycling. You're gonna do one of those.
Yeah.
Or music. Music, I guess, is interchangeable. But you know what I mean? Like there's maybe it's strictly a cultural thing. Just like people who are into this share this with each other. But I feel like there seems to be a little bit of a type of person.
Maybe it's because, like I was talking about earlier, I make music, but I absolutely see the connection between the mindset for programming and for making music. To me, they feel like very similar tasks. They kind of, I don't really know how to say it, but they take kind of like the same energy from me when I get home from work. Do I program or do I work on music? It's kind of the same.
Yeah.
I don't know, draws from the same well.
Yeah.
Physical activity like that feels different, at least to me.
Well, I'll say this, like, jiu-jitsu, a lot of people compare it to being like a video game. Because it very much is like something, the first day you suck. And then you learn a little bit and then you get better. And it's very much like applying an algorithm, really. Even though I was saying that sports are more of a complex system. Like, you learn this move and there's like a few different ways to defend it. And then you learn those and you practice those and then that move you get out of it most of the time,
Okay.
And there's a very clear progression to it, which I think, that triggers the complicated brain a little bit.
Absolutely.
I have this belt and then I have this belt and I have this one. And it's like, that's very video game-esque. I
think that's related to feeling smart is feeling accomplished.
Absolutely. Yeah. There are times in jiu-jitsu where you feel really smart. You're like, ooh, I got him with it because I made him think I was doing this and then I did that.
Right.
People say it's like chess. They compare it to chess a lot.
There's a lot of strategy in jiu-jitsu?
Yeah.
Interesting.
In sport jiu-jitsu, yeah.
Yeah. That makes a lot of sense then, that there'd be a lot of crossover. man, maybe I should try jujitsu.
Yeah, I mean, I don't really train anymore, but it's cool. It's fun.
Did you ever get punched in the face?
Not doing jiu-jitsu. I got punched in the face doing boxing.
Oh.
I mean, I might have got hit. Oh, a dude did kind of like drop an elbow on me, like as an accident. You will get bruised up a little bit. But it's cool.
Do you feel like you have the engineering mindset?
I think I do.
I think you do.
I think it took me a long time to realize that I did. Like, I definitely remember as a kid doing like word searches and crosswords and being like, yeah, I like puzzles, playing with the Rubik's Cube, that kind of stuff. I think it took me a while to like translate that to the computer.
Yeah. Yeah, because you were saying that you weren't introduced to programming. Do you think you would have taken to programming if you'd been introduced to it earlier? Like if that had just been...
Oh yeah, I think so.
Yeah.
And I think, because, I think it's similar, like back to the jiu-jitsu thing, right? Your first day you suck. And it's not fun, really, to just get beat up. But like once you start doing cool stuff and you start feeling like you're smart, then it's like really addictive. And that's what programming is like, right? Once you start doing stuff and you start making stuff and you start seeing like, oh, I can do that. I mean, there's a lot of different appeals that it can be, right? Some people just get really into performance. Mm-hmm. Some people just get really into as many users as possible or the coolest looking thing. But once you find that dopamine hit, you want more of that.
Right. Yep. I still remember those like early programming days as a kid, just being like, it just felt so good to, there's the feeling when you run your program and it just runs forever.
Oh yeah.
It compiles successfully, it runs, and then there's just that like, that's why I was saying in our episode about learning programming, I was talking about getting to an interactive program as early as possible. I think it's that moment for me where you run it and it's just, now the program is waiting for you to do something, right? It's, that's just a really exciting moment, I think.
Yeah. I wanted to say, like, I feel like we've been pretty down on complexity.
Oh.
Is there anything, like, good about complexity?
I think the thing about complexity is just, I almost think complexity is another word for, if you want to put a positive spin on it, I think complexity is another word for possibility, right? There's always if complexity means that there are some unknown unknowns in the mix, there's always the possibility there to break some of that complexity off into a piece and to tame it into a complicated system.
Yeah.
I think that, so, I don't think that we'll ever get to a point where there's no complexity in the world, that there are no unknown unknowns.
There'd have to be no people.
Right.
Right.
You'd have to, and what a like terribly boring world that would be, right?
Yeah.
Just if there was no unpredictability and no, nothing unpredictable ever, everything unfolded according to an algorithm. That's like some dystopian sci-fi novel.
Yeah.
So I think that's the upside of complexity, is that it's the possibility for new solutions. It's the possibility for you to discover what those unknowns are and make them known things, and to kind of like craft a recipe or an algorithm around it.
Nice. In a way, the complexity people are smarter than us.
Why do you say smarter?
Because they have more unknowns.
Yeah.
Or more. I mean, their problems are more challenging.
That's true. Yes.
Right. So maybe not smarter, but they have a more challenging problem to solve.
I think that's it. I think the problems when you have unknown unknowns are just infinitely more complicated.
You don't even know if you solved it, right? Like when an employee says that they're going through something and you tell them whatever you say to them, you don't know, was that the right thing to say? Was that what they needed to hear? Was that what the business needed to hear? Are those the same thing? I hope they are.
Yeah. Yeah, we were talking about geopolitical issues. Like, what's the right answer to any geopolitical issue?
Yeah.
It'll take you decades to even find out if what you did was successful, let alone the right answer. There's no right answer.
Yeah.
There's only really grades and degrees.
Yeah. Whose side are you on?
Let's do it.
Okay, so when you've got curly braces, like when you're writing JavaScript, and you've got your curly braces, do you put the curly brace on its own line underneath the like declaration, or do you put it on that same line?
Okay.
You know what I'm saying?
Yeah.
The block versus, I guess they're both blocks, but is that first opening curly brace? Is it on the same line or is it on its own line down?
This is a funny one. I think this is really good. In JavaScript, I put them at the end of after the if statement. They go on the same line as the if statement.
Okay.
In C++, they go on their own line.
Really?
Because it makes me feel smart. I don't know why, but putting the curly brace on its own line gives the code I don't even know how to describe it. It looks more scientific to me.
But that doesn't apply to JavaScript?
No.
Because JavaScript just isn't really
It's
a complex problem.
JavaScript's just a silly thing we're doing in the browser. It's not like really serious problem solving.
I've never written C++. I haven't really dug into that. I feel like I do both. Like I've done both. But I think most of the time I'm putting it on the same line. But I'm mostly writing JavaScript.
I think part of it is just that JavaScript feels for some reason like it should be more compact.
Yeah.
When it's in the browser like that, it just feels like... So I should say that, everything I'm doing is in browser. I'm not doing any Node or anything like that.
Mm-hmm.
But just spacing it out, putting the curly brace on its own line just feels like it takes up so much space in a web page.
It does. It takes up space, but like you were saying, that it does kind of feel nice when you got that block. Like it makes things more like, I don't know, rectangular, boxed in.
Yeah. That's the thing. It feels spacious. I feel like I can spread out a little. Like, yeah. 4 spaces and brackets on their own line. Like, oh man. Do you have another one?
I was trying to find a good image of this exactly, but I just see like style guides that are like, I don't know. Do you can do it on like this example is talking about putting the whole function on one line. When you've got like something really small, really compact, like.
Sure. If you have a function that can all fit on one line, sure.
I mean, yeah, that's obvious.
And especially in modern JavaScript, when you're like, double arrow and it's just a return statement kind of functional style. I'm a big fan of putting the function all on one line if you can.
Okay, I found there's a whole Stack Overflow thread about this. The dude asked a question. This guy says it doesn't matter. It does matter. Whichever style you choose, be consistent. Okay, all right. This guy doesn't have the engineering mindset, obviously.
Exactly. Uncurious mind.
All right, let's do another one. Well, we've kind of talked about this. Strong typing versus dynamic typing.
Yeah. I mean, since I work with Python and JavaScript most at work, I kind of feel like grass is always greener, but I would like to have a little more strong typing in my life.
I mean, I don't think strong typing ever really costs you much. If anything.
I think it costs you... I think it's harder to get your program right the first time, right?
Okay, yeah.
The compiler's going to yell at you and be like, hey, buddy.
But I will just say that, like, especially as a Python dev, like, I have chased down a lot of things that were ultimately a type thing.
Yeah.
That happens, like, a lot. Well, I mean, not so much anymore, but, like, at first, a lot.
Yep. Same here. And that's probably the most common kind of error that we see crop up, even in production, is just like, oh, this thing was none when you didn't expect it to. I would love to have some kind of strong typing there that was like, this wouldn't even be allowed to be null.
Yeah.
I kind of crave that in my life. And I have worked with, so C++ is probably the most strongly typed thing that I've done. And I kind of like it.
Yeah.
Yeah.
Yeah, I've usually liked it when I've done it.
Do you use TypeScript at work?
No. I mean, there's some stuff that I touch that is TypeScript, but largely it's JavaScript.
Yeah. I've always been curious about TypeScript for that reason.
But we do, like, there is typing in a lot of our Python code. Like,
oh, really?
With, I don't know what it is actually, but there's like some sort of extension we're using or something where we have types defined.
No, I think that's built into Python. I've just never like seen people use it.
That's it. Yeah, so it's not used everywhere. I think it was something that someone started doing at some point. And it's cool, I guess. I guess it's kind of what you say. I mean, like, it feels like a waste of time when I'm doing it. I guess because it is optional. But yeah, generally I think I think it's cool when we have static typing. I know there's a thing in Elixir. So Elixir has duck typing. And that's kind of like one of the big things that holds people back from it. Like I think a lot of the functional programming people are like, they're really into the static typing, which makes sense. And I know there's like a talk where like the creator said that static typing will never come to Elixir because it's like impossible somehow. I mean, I don't know nearly enough about it, but he was saying that there's just like no way that they're going to do that.
Why, yeah, I don't know why it would be impossible.
Yeah, I mean, it's a really complicated language. You know, it's built on Erlang and it runs on the JVM. I don't know. There's something in there. Maybe it's not impossible, but it's just like wouldn't be good. You know.
Yeah. I will say, you know, TypeScript and Python type hinting both are like. I do wonder, kind of when you were saying that they're optional, so they're just kind of a pain in the ass. Like, I wonder how much you lose by not having your entire code base. You know, both of those are designed to be kind of progressive, and you can kind of just like add types to certain parts of your system and stuff like that. But I always do kind of wonder, yeah, how much are you losing out on when you don't have it, when you don't have strong typing throughout? You know, you got this part over here that's like weakly typed and duck type and all that, and then like over here types are enforced or type hints or whatever.
Right.
It's like I almost feel like to really get the benefits of a strong typing system, you gotta be all or nothing. Maybe that's
so
not right,
I think maybe it's just because I found this thread somewhere. Erlang is dynamic.
Oh.
So I think maybe just Elixir would have to move away from just being like better Erlang and become like its own thing if it was going to do that.
Gotcha. Oh, I kind of forgot that Elixir is, yeah.
Yeah, the goal of Elixir is just be like Erlang but better, like a Erlang ++ kind of thing, I think. So.
You like Erlang though, right? Or sorry, you like Elixir?
Yeah, I haven't used it a whole lot, but I used it for a project and I liked it a lot. I think it'd be cool if it had static typing, but it's cool. Apparently there's some typing specs you can do, I guess kind of similar to like what Python has. You can like annotate stuff, but it's not like enforced.
When are those types checked in your Python code? Is it like when your code compiles to the PyC file or whatever?
I guess because it'll tell you, like, it'll complain if you have it defined and it doesn't agree. It'll tell you. So yeah, I guess. I don't know where it really happens at.
That's cool. No, I'd like to try some of that out.
I feel like someone's gonna think I'm dumb because I don't know how the Python typing works. Because it's like new, right? That's like a newer feature.
I thought it was, I don't know, I thought it'd been a few years at least.
Well, I mean, a few years would be like the version I'm on.
Okay, yeah.
You know what I mean?
New-ish. Certainly, like, Python 2 didn't have it.
Yeah. Yeah, I think optional types is like, okay, what are we doing here? Unless you start your project with it.
Yeah, you really have to. Yeah, I think it just makes so much more sense if the whole project is doing it. Because the second you run into problems with your type system, or your types not matching or whatever, you're just going to be like, all right, everything is any now. And, I'm just not going to use types for this part because it's a pain in the ass. Instead of going back and like fixing your type hierarchy or whatever. Just feels like optional types will always end up being no types at all.
I found this Reddit thread. Everyone's like, "Oh yeah, I can't even use Python without it. I type everything."
I might just like start typing some stuff at work. See what happens. See if
you might as well. I mean, yeah. There's no reason not to, right?
I think if someone who is not aware of it tries to run my code and is like, "The hell's this?"
Yeah, but I mean, the error is pretty clear.
All right, I'm going to make that my goal. I'm going to try that this week.
Nice.
I'm just going to introduce some types and see what happens.
Oh, yeah.
All right. Well, we're over an hour. Should we wrap it up?
Let's wrap it up.
That was a crazy episode. That was a wild ride.
Yeah, somehow we got here.
All right. Well, we'll catch you guys next time.
Yeah. See you.
1X Developer Podcast.
Hey everybody, this is Colin. First and foremost, I want to thank you all for listening to this episode of the 1X Developer Podcast and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1X Developer Podcast. We're also on YouTube at 1X Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1X Developer Podcast. Thanks so much. See you next time.